We're going to start off our unit into linear equations by looking at patterns first to understand how linear functions can be created. So we're going to use patterns to represent linear functions. So the first thing we need to do is look at a set of figures. And what you'll start to see is a set of patterns. And to kind of determine what pattern we are dealing with, the best way to go about this is to complete the table below based on the figures. So we're going to use the change in the number of dots to figure out how many dots would be in the figures not pictured. So we're going to see what we can kind of determine from this diagram. So you'll see that the chart starts at figure 0, but we start at figure 1 in our picture. So we're going to look at that and say picture 1 has 1, 2, 3 dots. Okay. Figure 2 has 1, 2, 3, 4, 5 dots. Figure 3 has, again, you can count 1, 2, 3, 4, 5, 6, 7. So you can fill in your chart there. And what you'll start to see is the change in the number of dots from 3 to 5. Hopefully you'll understand that 3 plus 2, so there's a change in plus 2 from each one. So by this point, you should start to see a pattern that there's a change in plus 2. If you were to draw figure 4, so if the question was to ask you, say, well, what was figure 4? You'd be able to figure out, well, you start with that main dot, that main black dot, and then you have 1, 2, 3 gray dots, and then you'd have to add 1 here and 1 there. So in total, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. And when we look at our pattern on the chart, we'll see we go from 3, 5, 7, 9. That makes sense because we're going up by 2 each time. So the change is plus 2. So if we go backwards and we look at, well, if the change is plus 2, what would it be if I went back to like figure 0? What would be my starting point? So you can think of it as 3 minus 2. So our change would still be 2. So if we started at 1, we would continue the pattern backwards. And figure 0 would just be 1. And this is important coming up later when we try to figure out an equation or an expression to represent what we're doing here. So we actually already figured out how many dots would be in figure 0. We figured out that there would be 1 dot. And how did you determine your answer? I counted backwards 2 from 3. And if I want to make my answer a little bit better, to continue the pattern. Next we have the question, describe what the change from figure to figure looks like. So we've already kind of talked about like what it looks like for numbers, and we sort of talked about it right here about what it looks like, but let's try to describe it in words now. What changes in the images as you move from figure 1 to figure 2 to figure 3, etc. So now let's try to put that understanding into words. So as we change from figure to figure, we see, and your answer here can vary. This is going to be my answer. So we see 1 dot added vertically. So vertically is that dot that's added up here, like in a vertical line. And then we also see and 1 dot added horizontally. You could even add more to that by saying we see like capital L shape get bigger. Okay, so what I've tried to do here is describe in words the change and like what it looks like. What looks like is I tried my best to do. How does it change in the look? This is the part where like the math comes in, like why are we all doing it? And here it says, looking at the parts from B and C, write a general rule or an algebraic expression that represents the total number of dots in a figure, where X represents the figure number. So we need to look back up here and say, well, if X determines the figure number, so this is going to be X. So this is saying, and I'll show you what this means, but it means that we're going to, instead of putting a number down for figure, we're going to put X as like the unknown. So kind of going back to our last unit. And then we're going to write an expression. And what's really important with when we're writing an expression is that we want to look at like what do we start with and what's the rate of change. And in grade 8, you guys should have talked about that the rate of change is actually the numbers in this column here. This is also determined as rate of change. So my rate of change, or how much I change from figure to figure, is I change from +2. And this is important when we go to write our equation, our expression, is we must think, well, whatever figure number I have, so whatever figure number I have, which is X, and if means I will like have a rate of change of 2, so I'm always multiplying by 2. So no matter what the figure number is, I'm multiplying 2, but I have to add what I started with. So it's like, I like to tell people, like, think about what you started with. Like, imagine you were ordering a pizza, and it's a really cheap pizza, and the base price of the pizza is $1. No matter what you're going to do, you're going to be paying $1 for a pizza. And then toppings, each topping, which in this case would represent X, you would be charged $2 per topping. So $2 per topping plus the base price of the pizza would get you the total pizza. So when we're looking at a question like this, the number that goes in front of the X, this is always the number that's the rate of change. In this case it was how many dots were added each time. And then this number, the 1, this number represents what we started with. Or we could also say this is our base. Or this is how many dots we have, dots at figure 0. Okay, so when we go and we look at this equation, I'm just going to use another color, but if we look at this equation and we think, well, we already figured out 4 by kind of analyzing, and if we could probably figure out 5 by continuing the pattern, like 1, 3, 5, 7, 9, well, figure 5 will have 11 dots. We could just add that, and we could also like go back and we could draw a picture to determine this. So we could go back here and I'm just use another color, and we could start with our, our figure 1 is like this, figure 2, figure 3, figure 4, figure 5, and we see that if we had figure 5 would have 1, 2, 3, 4, 5, it'd have 11 dots. And we could figure that out by easily counting. But how that works in this equation, if X is equal to figure number, and in this case, our figure number is 5, and that means X is 5. And going back into substitution, if I put 5 back into this equation, I have 2 times 5 plus 1, and if I solve by algebra, 2 times 5 is 10, 10 plus 1 is 11. 11 is the same as 11. So you think, well, why do I have to do this equation when I can just count? Well, what if I give you the extension of, well, how many dots are in figure 40? So how many dots in figure 40? Well, yeah, you could draw, you could count up, but that would take you a long time. The faster way would just be to take your original equation, 2x plus 1, and plug in. So figure 40 is x. Then I'm going to plug 40 in for x, and I get 2 times 40 plus 1, and this would be 2 times 40. Well, 2 times 4 is 8. Add a 0. Then I know that figure 40 has 81 dots. And just looking at the last question here, it says, explain what each part of your algebraic expression represents. Well, I actually already talked about that when I said my expression is 2x plus 1. This is that's what's called an expression. Expression is an algebraic equation sort of without the equal sign. So expression is without the equal sign. So it says explain what each part of your algebraic expression represents. Well, I already told you that the 2 is the rate of change. And 1 is like your base, or the number of dots at figure 0. So that's kind of how you use a pattern to determine an algebraic expression so that you can solve it. And the whole point of this, so the whole point of this is that you can solve any figure number. So you can put any figure number like figure 40 in, or you can put figure 53 in, or you can put figure 1,000 in, or 1,000,000 in, and no matter what you do, you'll always be able to figure out how many dots are in because you're able to use your expression and you don't have to keep counting.